so this is force. Today we are going to learn about forces and motion. Okay. Now, look at the diagram. So what are they doing?
Skydiving.
Skydiving. Okay, what do you know about skydiving? Pernah buat diving ni ke? Skydiving ke apa? Sepak orang. Kena mama kan? Jap. Okay. Duduk diam. Okay, so now before we talk, we move on with force and motion. Okay, so last time I asked you to do homework about electromagnetism. Tak sempat nak ajar sangat kan? Okay, so now let's. Okay, this is about electromagnetism. Yeah, last time you did the homework. Okay, so what is a force? So force, okay, force is, okay, this is the definition of force. What is it? It is a push or a pull. Okay, very easy kan? Kalau orang tanya, what is a force? So no, it's very, the definition is very simple. So what's the definition? It's a
push or a pull.
Yes, it's a push or a pull. It's very simple. Okay, next. Okay, next. Okay, we have many kinds of forces. Okay, there are many types of forces. So here are a few of them. Okay, so kalau awak tengok, can I read this one? Okay, types of force. Okay, we have gravitational force, okay, we have weight, frictional and elastic force, and buoyant force. Okay, so what is gravitational force? Okay, gravitational force is a force due to the pull by the earth. Okay? So, gravitational force always pointing to the center of the earth. Next, we have weight. Tapi dalam in your daily life, you cakap weight. Kalau kata, what is your weight? Awak katalah, oh, my weight is 60 kg, for example. So, in physics, this is not actually weight. Okay, what you are saying ni, 60 kg, kalau awak stand on a weighing balance and then it says here 60, so this is not actually weight. In physics, we call 60 kg tu adalah, what is it?
Mass.
Yes, that is mass. Okay, so what is weight? Weight is a force. So, from this mass, you can calculate your weight. So, your weight is mass times gravitational acceleration. So this is for your information. Yeah. So what is your mass just now? Saja nak check ni, awak pay attention ke tak? What is the mass mentioned just now?
Wait.
What is the mass tadi? Example yang saya bagi tadi. 60 kan?
60.
So gravitational acceleration, okay, so this one is fixed value. Katalah 10. Okay, gravitational acceleration. So what is the weight? So 60 times 10, that is 600 Newton. So your weight is 600 Newton. Now, what is the other forces? Okay, frictional force. Okay, now you see in this diagram, can you see my cursor? No. Yes or no? Okay, here we have two arrows. Do you see the two arrows?
Yes.
Okay, one arrow pointing macam slanted up tu kan, naik atas tu to the right, and then the other arrow pointing downwards to the left. Nampak? Both are red. Do you see them?
Yes.
Yes.
Okay, now one is longer than the other. Right. And you see this person is pushing the box upward. Okay, or along the ramp. Now, so if he pushes hard, where will the box move? Where is the direction of the movement of the box? Upwards or downwards?
Upwards.
Wood.
This way, to the right, kan?
Yes.
Okay, so the longer arrow is the arrow representing the force by this student. Okay, now the shorter arrow, what is that? So this shorter arrow is the
Gravity. Tarikan gravity.
frictional force.
Force.
Sebenarnya awak tak belajar lagi. So, it's okay if you cannot answer. So, now you may ask yourself, what is frictional force? Okay? Now, keep that question in mind. Tulis dekat mana-mana. After this, you're going to tell me what is frictional force. Okay, next, we have another type of force, which is elastic force. Now, what do you see in these diagrams?
Rubber band.
Diagram. Rubber bands. Okay, you have rubber bands at home. So, you know they are elastic, kan? Okay, so this is also a kind of force. Okay, and we have another force called buoyant force. What do you see in the diagram?
Ship.
Okay, it's the ship. Okay, now the ship, is the ship sinking or floating?
Floating.
Floating on the surface of water. Now, what causes, what enables? Apa yang membolehkan? What enables the ship to float in the ocean? So the answer is buoyant force. So what is buoyant force? So inilah yang you are going to learn after this. Okay. So far, so good. Do you have any questions yet? Oh, tak ada. Okay. I have a lot of questions. Tak apa. Okay. Ni saya tak suka pakai ni ni. Right. Okay, now this is, I wanted to ask you to do this one. Okay, and then you show us lah, awak buka video and then you do this and then you tell me. If you have a ball and then you throw the ball up in the air, what happens to the ball after that?
The ball will fall to the ground.
Yes, then the ball will fall back to the ground. Agrees, everyone? I'm sure everyone agree with that. Okay,
Yes.
so what makes the ball fall down?
Because there is gravitational force.
Yes, exactly. Excellent. So the one that makes the ball fall down is the gravitational force. Okay, excellent, Eliza. Okay, next. Okay, so this situation, what is the situation? Place a wooden block on a table. Now, this is the diagram. This is a wooden block. Okay. Why does the wooden block remain in its position? Now, the wooden block, okay, kalau awak ada apa-apa, what do you have in front of you right now? Maybe your laptop. Is your laptop moving right now?
No.
Ataupun your phone, is it moving? No. So, what makes your phones, your laptops, ataupun your book or this wooden block in this diagram, what makes it stationary? What makes it remain in its position? So the answer is, there is normal reaction. Okay, what is that? Normal
Reaction.
reaction. So now you learn a new, Allah, saya tak boleh tulis. So now you learn a new force which is what we call as normal reaction force. And normal reaction force is always dia akan opposite to the, okay, what is always there adalah weight. The wooden block has weight. Okay, and weight is always pointing downward. So normal force, normal reaction is pointing up. And the value, selalunya kita guna simbol R. Normal reaction, simbol R. And then kita buat arrow anak panah ke atas. If the object remain in its position, kita kata the object stationary, not moving. Kenapa? Because value of R equals to value of W. What is R just now?
Normal reaction force.
Normal reaction force. What is W?
Weight.
Weight. Very good. So if the weight is 10 Newton, the normal reaction also 10 Newton. So that's why when you are asked to draw arrows, you must make sure the length of the arrow is the same. Length of arrow. Sebab length of arrow is telling the magnitude. Apa tu magnitude tu? Nanti saya akan sebut. Okay, tulis dulu dekat buku nota. I mentioned the word magnitude. So what is magnitude? These are the question that I expect you to answer lah, to ask me. Sebab of course you don't know magnitude semua tu. Ataupun ada yang tahu what is magnitude? Ada yang dah baca buku dulu? Okay, so it's okay. Now then, okay, what you need to do secondly, push the wooden block. So you are going to push the wooden block. So let's say now this diagram here, if you push the wooden block, what happened to the wooden block? It will move, kan? If you push it in this direction yang ditunjukkan ni, if you push in this direction, the wooden block will move. But will it move forever? Awak push sikit je. Adakah dia akan terus jalan non-stop? No. Okay, cuba awak buat sekarang. You push sikit awak punya laptop ataupun your handphone tu. Dia akan push, lepas tu dia akan stop, kan? Betul tak? Betul. So what causes the block ataupun your laptop or your handphone or whatever in front of you you push tadi tu, what causes them to stop? Tadi someone dah jawab dah answer dia. Tadi someone dah mention. What's the answer?
No.
So force is here. So what causes it to stop?
Friction.
Force.
Yes, friction. Very good. And the direction of friction is opposite to the force you apply. Always. Okay? Keep that in your notebook. Friction must be always in the opposite to the applied force direction. Now, what is the difference between diagram A and diagram B? What's the difference?
The second diagram has sandpaper.
Okay, why do you think why we want to have the sandpaper? What are we trying to prove? Now, based on your experience, okay, do you know what is a sandpaper?
Yes.
Okay, so
Yes.
from your experience, how is the surface of a sandpaper?
The
Rough.
Is it very
sandpaper is
smooth
rough.
or rough or what? You see,
Rough.
very rough. Compared to the table just now, do you want to buy a table that is very rough? Tak nak kan? This one smoother. Takkanlah kita nak meja kita rough, nanti lukalah tangan kan? So, now, is it harder to push the wooden block at a rough surface or at a smoother surface? Which one is harder? Of course, like at rough surface. In fact, maybe on the sandpaper, when you push the wooden block may not move at all. Maybe, kan? Why is that? Because the friction here is higher compared to the friction on the table. Okay, why the friction higher? Because the surface is rough. Okay. Okay, next activity, hang a spring. So imagine that you have a spring. Where is the spring? Mana gambar? Ni gambarnya ke tepi sangat. Okay, so let's say you have a spring here. Okay, awak pernah buat eksperimen kan during lower form? Bukan lower form, sekolah rendah. Pernah tak buat eksperimen using your spring? Have you ever done that?
No.
Tak pernah Okay, but it's okay. But do you know if you have a spring, if let's say awak ada mechanical pencil, of course your mechanical pencil ataupun pen tu ada spring dalam tu, betul tak? Awak
Betul.
keluarkan, awak gantung apa-apa, awak ikat tali, awak gantung apa-apa on the spring, what will happen to the spring? Ataupun you pull the spring. So the spring will extend.
Expand.
Okay. Ataupun now awak ambil awak punya pen, awak buka dalam tu awak keluarkan spring and then you push. You push the spring. You push your spring tu. What will happen? It will no longer extend. Dia akan compress. Okay?
Compress.
So a spring can extend or compress. Now, so when the spring extend, there is change of the length, kan? Ataupun when you push the spring, the length also will change. So for example, this is the original spring. So the length of the spring now is L0. Saya buat simbol L0. Usually dalam physics, not tu means original lah. Original, before, at zero punya pushing. Now if you place something on the spring, so of course this object has its own weight. So now we have a new length. So the new length kita kata L1. So we have extension. So what is the extension of the spring? So the extension of the spring is L1 minus L0. So where is L1? So where is the extension? So actually the extension is this one here. So ini perbezaan dia. So this is the extension. Symbol extension X. Do you understand what I'm trying to say? Sama juga when you compress. So this is the original length. Now if you compress the spring, now the spring becomes like this. Kan? So this is the new length L2. So what is the extension? Ni situation 1, ni situation 2. Extension, which the symbol is X. is L2 minus L0. Dapat negatif. Tapi kita buat je lah supaya jadi positif. L2 minus salah lah. Betul lah tadi. L0 minus L2. Nampak tak? L0 minus L2. Kenapa L0 dulu minus L2? Sebab L0 longer. L2 shorter because you compress it. So what kind of force do we have near? So this is elastic force. So elastic force, okay, a spring has elastic force. And then next situation, this is an activity. Okay, awak boleh buat sendiri. You pergi dekat dapur, ambil satu basin ataupun ambil a pot and pour water into the pot, kan? And then awak letaklah apa-apa yang you think you can float. Let's say apa contoh yang boleh float in water? An egg maybe awak letak, kan? Right. So this is so kalau egg tu baru dia akan float, kan? Ke dia akan sink? Ataupun maybe ice ke, awak letaklah ice. So they will float. So what causes the egg or the ice or the wooden block in the diagram floats? Okay, so you do your observation and you answer my question. Apa yang menyebabkan dia float? So the answer is buoyant force. Okay, next. Okay, so these are the three or four activities that I want you to do, and I want you to do at home, and then ambil gambar or make a video, very short video, TikTok or whatever, and then submit to me. Okay, I will write a platform dekat dalam Telegram tu ataupun at Teams. Okay, everyone are going to show the activities yang awak buat. Sandpaper tak ada, no problem, you cari je 2 different surfaces. Okay, at home. Alright, so awak boleh guna untuk sabun licin tu, awak boleh letak sabun ke apa, kan? So to explain these forces. So now these are types of forces that we have. Okay, ada banyak. We have gravitational force. Okay, so you need to know the definition of each of these force. Okay, gravitational force is the force that points toward the center of the earth. So this force causes all objects that are thrown upwards to fall back to the earth. So this explains the first activity just now, which was about the ball. The ball will move downwards. And then we talk about frictional force. So what is frictional force? So the definition of frictional force is the force that, what's this word? What is this word? Resist movement. Apa resist tu? What is resist in Malay and Malay?
Menentang.
Menentang, against. Okay, dia akan sentiasa menentang. Dia akan sentiasa against. Against what? Against the direction of the force given to it. Okay, and then buoyant force. Buoyant force is thrust. Okay, nama lain dia adalah thrust. So what is thrust? Thrust ni, okay, is another name for buoyant force, and this always pointing upward. Nampak Dia always pointing upward. And then we must just mention about elastic force. Okay, elastic force exists when a material is stretched or compressed. And then we talked about weight. Okay, weight is always pointing downwards. Kenapa? Because it is the gravitational force acting on an object. And we have normal force, which is always pointing away from the weight. Okay, Normal force is the force produced when an object is in contact with a surface. Okay, so how many forces do we have now? So you need to know each of them, and then you need to know to be able to give examples of each of them. Ada soalan?
Tak ada.
Okay, next we learn about characteristics of force. Okay, now you need to know that force, okay, is a vector quantity. Vector quantity. Class to actuary, what is the meaning of vector quantity? Anybody knows? What is the meaning of vector quantity? Vector quantity. Ada yang tahu tak? Ya?
Has both magnitude and direction.
Very good. Siapa yang jawab tu? Terima kasih. Right. Vector quantity is a quantity that has magnitude and also direction. Keep that in mind. Okay, you need to know this one. This is very basic about vector quantity. Kita ada dua. Satu, okay, quantity. What is quantity? Now, let's say I have chocolates. Okay, saya pergi kedai, saya beli 10 coklat. So, what is the quantity of chocolate that I have?
10.
10 lah, kan? So, that's the quantity of chocolate. So, that quantity, kita boleh categorizekan into two category, which is vector quantity or scalar quantity. So, in physics, we always classify quantities. Some are vectors quantity, some are scalars quantity. Okay, so vector quantities are quantities that have magnitude and we must consider the direction as well. But scalar quantity, the quantity we just consider about its magnitude only. Now, did you remember earlier this class I mentioned about magnitude? Ingat tak? So, now my question is, do you know what is the meaning of magnitude?
Yeah.
Quantity or value of measurement.
Yes, exactly. So just now about the chocolate, what is the magnitude of the chocolate? What is the magnitude?
Quantity.
Quantity, kan? So berapa magnitude tadi? Berapa saya beli tadi saya cakap? 10. So the magnitude is 10. But do you think we need to consider about direction of the chocolate?
No.
No, it's not important. Who cares about the direction of kan? As long as dia masuk mulut sedap, okay lah. But for force, we must consider its direction. Tadi bila kita discuss awal-awal tadi, we talk about a few activities just now. Kan, we mention about direction. Saya cakap to the left, to the right, and then upward, downward semua. So force is very important and you need to know what is important about force. You need to know it's a vector quantity. Then you need to know what is vector quantity. Vector quantity, it has magnitude and direction. And another thing that another term that you need to know is point of application. So what is point of application? Now look at this diagram here. Now yang saya klik ni ya. So the force applied. Okay. Now nampak tak force tu ada magnitude. So what is the magnitude applied?
10
Newton. What is the direction? to the left. Okay, so a force has magnitude and direction. It's a vector quantity. And then the point of application of force. Di mana? Where is the point of application of the force? Di mana is the point of application? Jawapannya ialah kat mana?
The hand.
The hand. Sini. Now look at this diagram, this example. Okay, okay, tak nampak ni example ni. Okay, awak tengok ni. Okay, so this hammer nail wooden block. Okay, this one is a little bit difficult. Okay, for you apply force here by your hand, of course. Takkanlah force tu by the hammer. Now, where is the point of application? So now you know the term of point of application. So for force ada three important things lah: magnitude, direction and point of application. So maybe so look at this situation. Teacher, how do we measure force? Do we use a meter ruler? Is that the instrument that we use to measure force? Meter ruler? Do we use meter ruler?
No.
Oh, so what do you use to measure force?
Spring balance.
Yes, we use spring balance. Okay. Pernah guna tak spring balance?
Tak.
Tak.
Tak pernah. InsyaAllah kan kita ada rezeki balik-balik maktab, kita akan buat eksperimen ya. Okay. So here the teacher says the magnitude. Remember the word magnitude? Again, what is magnitude?
Quantity.
Quantity or value.
Quantity nilai, value. Okay? Magnitude to value. The value of the force. Seolah-olah cakap macam tu. The magnitude of the force is obtained by reading the scale on the balance. Okay, so that is a diagram of balance force. Now, what is the unit of force? Anyone knows? Tadi saya dah cakap lah banyak kali, ada antaranya kita sebut tadi force equals to 10 Newton. So 10 ni adalah the magnitude, the value of force. And ni what is that?
Newton.
Yelah Newton. What is Newton?
Unit.
So Newton is the unit. Okay? Right. So now you know force, we use unit of Newton. So force is measured in Newton. When you want to spell it, we use small letter Newton. When you want to write the symbol, we use capital letter. Okay, so this is named after Sir Isaac Newton. Alright, so he says that he was the one who discovered about gravitational force. Okay, and then we need to know about action-reaction pair. Okay, so look at the car. The car is stationary, not moving. So maksudnya what are the two forces acting on the car? So the car berat ke ringan? Boleh angkat tak kereta? Ada siapa boleh angkat kereta kat sini? Ada?
Saya.
Uyo, kan? Kereta mainan boleh laut, kan? So, of course the car has weight. So, what is another force that makes the car stationary? This is a question. Just now we discussed about this already. Yay! Reaction force. Okay, dia punya length tu sepatutnya sama panjang. Okay, now look at the apple and the book. Same. So if we are focusing on the apple, so the apple has its weight downward. Okay, walaupun dia hanyalah an apple, but of course it has its own weight downward. And then it has another one, normal. Word that the table stays stationary. So okay, we are saying that there is always action-reaction pair. So this is explained by Newton's third law. So Newton's third law states that for every action force, there is a reaction force of the same magnitude but in the opposite direction. Okay, awak kena tahulah. So Newton's third law, same magnitude but opposite direction. Okay, so tengok gambar tadi. Same magnitude. So bila awak kena lukis kalau dalam exam kena lukis, awak kena lukis dia sama panjang. Ni sama panjang dengan ni sebab same magnitude tapi beza direction. Okay, good. Alright class, I think that's all for today. I want you to look at this as your homework on your own. Okay, discuss these 3 situations in your notebook. Okay? Alright. Sorry for the tadi kan earlier this tadi kelas banyak gangguan daripada anak saya. Okay, so hopefully you learn something today.